And this basically means that we are online here. Welcome to InSession again.
Hello, everybody.
It's the third iteration. Whoops, I knew I would make that mistake. Damn it. All right, let's redo that. There we go. There we are again. Welcome again. So yeah, third InSession, middle of May, no, June already. And we have Eric with us. So let's introduce each other maybe, and Eric, you'll start.
So with us today we have Isabel. She's the community manager here at Derivative, and she's played a huge role in getting the community to where it is today through community initiatives like the TouchDesigner Summit or InSession. And with that, I'll throw it over to her.
Hi, everybody. I will introduce Marcus, who probably doesn't need much of an introduction because he's famous on multiple levels. First of all, he went on this incredible tour with Rush when he was an intern with Derivative. We can't say that enough, but he was for 6 months touring around on a real rock and roll setting. But other than that, Marcus has been with Derivative since 2006, and he's developed a lot of the tools that most of you probably use. Anything that has a kind of German-sounding name, like Zuweise and Kammschnappe and Zeitline, that would be Marcus. And actually, Marcus and Eric did all things laser for TouchDesigner. And of course, Marcus, other than his work at Derivative, he also has a big artistic practice and does a lot of live performances and visuals. And I could go on, but I'll pass it over to Marcus.
So much praise. Yeah, and I'll introduce Eric. Eric came to us as a co-op in 2016, I believe, and then 2017 joined full-time. And since then, yes, we have been working on the laser stuff with lots of Zollinger laser animation. He helped us with the laser chop, and Eric packaged it up. And also all the web that, Eric, that's you as well.
Yeah, that's right.
Plus, lately, all the dynamics, so bullet and flex, and coincidentally, I guess that's what we'll be talking about more today.
Yeah, that's right.
That's all what you've been working on, FBX, importing. There's a huge range of things that you did in the last couple of years. So that's you, Eric.
Very productive. So for those of you who don't know what InSession is, if this is your first time, basically it's this idea we've had for a long time, but we decided to implement it once this whole pandemic and quarantine thing started. But basically, our developers spend some time on the stream with up to 3 different community members and address questions, problems, and all things optimization, all things to do with optimization in TouchDesigner. And to apply, you go to derivative.ca/InSession, and you read the instructions, and then there's a form that you fill out, and it could not be any easier. So we encourage you to hit us up.
Yeah, exactly. It's really easy. And we made the URL easier. So derivative.ca/InSession, no more numbers or long words. One person who filled it out was Somil Metha. And I guess we'll be seeing now Somil.
Thank you. Hi, Somil. Thank you so much for joining us from Jaipur, India. Northern India, I believe. It's where you are right now.
That's correct, yeah.
Yeah, and we were talking a bit about how you got into TouchDesigner. Basically, your background is graphic design, which I think is pretty clear from your Instagram page. But you work at an agency that specializes in interactive experiences, and you're an experienced designer there. So you don't use TouchDesigner at work, right? You just started learning during the pandemic?
Yeah, so I was introduced to, I mean, I've left that agency, I think about 2 years back to try and start my own practice.
Okay.
So I found out about Touch because I used to see all these really interesting projects from like Bytevoid and Scylla and Sweta, where, you know, you used to see that the basis of how they were adding all these systems together, from lasers to projection to LEDs, was TouchDesigner. So that was the main thing that intrigued me to learn Touch.
Okay. And so how did you go about learning? I'm always curious, like how you found your way around, you know, like what tutorials did you do? What assets were helpful?
So firstly, I mean, I think everyone starts with Matthew Ragan's tutorials.
Who?
Like
Matthew?
that's universal. So I have to thank him because he had a lot of detailed tutorials with a lot of like technical aspects of it, and he has really good intro into all the different kind of chops and operators that you can use. And then I think secondly was a lot of Paquitas as well, which is kind of like he does a lot of visual GLSL. Basically, is how I would describe all of his patches are because he does all his math in tops.
In tops, correct.
Yeah, and secondly, I think for a lot of the visual aspect of like how to make things look nice, it was a lot of Lectronauts tutorials as well. So that was the base of it, and then I would refer to the doc here and there to sort of, you know, clarify things as well.
Excellent, excellent. So what do you think? Where do you think this is all heading now that things are kind of getting back to normal in India, or are you going to start trying to find other touch designer people?
So I actually spoke to someone today, and we were talking about how he was also interested in starting meetups. So hopefully, you know, growing a larger community here. And I'm specifically really interested in building interactive installations using data and all sorts of different things. So I think that's what I've been focusing on. That I already have one in the works as well. So I'm just figuring out funding for it and where to put it up, basically.
Great. Okay, so we will leave details on how to contact you on the YouTube video, but you can definitely contact Somil also via his Instagram. And with that said, are you ready to dive in with Eric?
Yeah, I can't wait.
Yeah, okay. Okay.
Yep, you guys are basically. You guys up. You can go ahead.
All right. Okay. So I think we'll start with just a brief introduction to Flex in TouchDesigner. Flex is a particle simulator made by NVIDIA, of course, for rendering particles as fluids, cloth, what else is there? Soft bodies. In TouchDesigner, we support currently only the fluids as well as static shapes. So now how do you go about doing that? We have a few different dynamic nodes here that you can find under the component page. The main one will be the NVIDIA Flex Solver component. You put that down, it's sort of analogous to the world that everything operates in. And the things acting in that world will be done through the actor component. And the Flex Solver component, essentially what it does is upon starting it, it will update the transforms of any actor bodies inside the simulation. So let's just go through and look and see. These are all the snippets, by the way. You can find these on the Learn Op Snippets page or talks under the Flex Solver component. So the first example here we have a Flex Solver component here, and inside we have one actor component. And if you're familiar with Bullet, then you've probably used the actor component, but because it's used in the Bullet solver as well. But if not, I'll go over some of the parameters here. So this actor component here is a fluid, and I'll run it here. And so it acts like a fluid, and that is done through the actor component by changing its kinematic state to dynamic and going over to the flex page and choosing the flex type as fluid. And it's done it's done in the same way that you would instance geometry. You go to the instance pages here, and then you can use an input instance or an instance op to create your instances here. So we're going to have 100,000, or sorry, no, 25,000 points created here. And in addition to using or creating fluids using the instance operator, you can do emission as well. And what that, so here we have 4 emitters, and they're cloned in here. And what these are doing here is you create a max number of emission particles, 25,000 in this case. You set the emission size, the emission speed, and it will automatically create instances for you in the simulation. So you don't have to worry about setting things up with an instance operator. And this will take the transform from the transform page here, and it will it will by default point to -Z. Okay. So that being said, why don't we jump over to Somil's file? I think we'll get a bit more familiar with, or we'll answer some questions here. So first things first, let's just have a look around the network and see what's going on here. So what Somil has done here is he has a flex solver component here, and that has a bounding box, which he's done with this one here. And so this is the border of the simulation. So you can see with the line material here that he's defined the boundaries here. And he has one actor component emitting a fluid from the top, and I'll just run that here. And I had a look at your file at the beginning here, and the reason it's not moving right now is just because the Q velocity is turned on. So it's just trying to hold all the particles to 0 velocity, but it's emitting, so it's sort of slowly pushing them out. Okay, so we started that. He has a audio file in here that is generating a kick and snare. And Somil, where did you get these components? Did you make them yourself, or?
Yeah, so I built that component myself, because the audio analysis one was like there's too much data basically. Sometimes you don't need all of the things that you have in there. Okay.
Yeah, so you're grabbing the snare here and the kick, and the snare, I believe, is running what is it doing? Yeah, it's changing the transform of these 3 platforms basically.
Yeah.
And you have one feature of Flex is you can grab some data buffers from there using the Flex top. So what you're doing here is you are grabbing a buffer for the position, texture for the position. This is the position of these particles here in texture form, and then the velocity as well. And what you're doing here is you have a texture lookup essentially, where you're changing all the velocities, and then you're grabbing a color from the ramp. So the slower the particle, the more blue it is, and the faster it is, the whiter it is.
Yeah, I hope I did it right, because that was a bit of a test in, it was kind of, I wasn't exactly sure how to convert velocity into speed, because essentially that's what I was trying to do.
Yeah, it looks more or less correct to me. I think something you could do maybe because right now you have some pretty strong colors in there. Maybe you could decrease the range a bit to soften the edges of the color. Because when you have this like this here, this is all very white, and then this makes it a bit more gradual, perhaps. But yeah, that's good. I like what you've done there. So you have an actor component emitting. but you're not actually using it to render right now. I think that's because of it's a bug with the instancing in fluid emitters, right? So what you've done as a workaround here is you've put down a geometry component, and you've instanced using the position buffer from up here. This is your instance operator.
Mm-hmm.
And then in addition to that, you've used the velocity color here to map the colors onto each sphere, right? Okay. And then you have you have the 3 static shapes here, which are being transformed based on the snare. Okay, so if I had a look around the network, let's dive into some questions here. Let me just grab the first one. So you say, when the aqua-colored ledges inside the main cube move, some of the particles pass through them, right? Why does this happen, and how can I resolve them? So the crux of the issue, I would say, is because here you have a static shape that you're transforming, but because it doesn't have any velocity or anything like that, it's essentially teleporting through space. So you can end up with issues of it clipping through objects. But Flex does provide. So if you go to the property page on the Flex Solver component, you get a whole list of simulation-wide properties, and that is the keyword there, simulation-wide. So these are the properties for the entire simulation, including particle radius. So if you set the particle radius to 0.1, any actor component that's a fluid inside the Flex Solver simulation will have radius 0.1. But nonetheless, you have the important parameter here for this problem is the collision distance. So what this collision distance does is creates a margin around any of the collision shapes, and so that'll give you enough margin for error where if you are moving it kind of quickly, like right here, you can maybe up this to 0.1, and then let's just see here. And so if you recall what it used to look like, hold on, let's stop spinning it just so we can see it. Yeah, so if you move it to 0, let's do something really low, 0.01. So in this case, the margin is there's a very thin margin around any of the collision shapes. So any movement on a static shape where you're transforming it in space, if it's too much, any of the particles are just going to clip straight through. So in this case, 0.1 seems to be fairly sufficient. That also happens to be the radius of the particle. So do you have any questions regarding that?
No, that makes sense. The only thing that I tried with the particle width, but it looks like you can see that it's a little spaced out. At least what I'm seeing on the YouTube, because.
Yeah, so I think the reason for that, you mean the particles are very close together, right?
Yeah.
Yeah, so I think that is because of the discrepancy of the sphere here that you're rendering with and the particle radius. So this is slightly smaller than what. So I think you'd want it to be about. Actually, no, you'd want it to be about 0.1. I think. No, it's too big. I think 0.05. So that's more in line with what the particle looks like inside the simulation, I believe. So the problem there was just that there was a bit of a discrepancy, and so there was a gap between the sphere visually and the sphere as a collider. So another thing that you could do to get around this problem, if you don't feel like, or if you don't want it to up the collision distance too much, because you can get very distinct lines between shapes if you push it too much. You could clamp the speed, but that won't affect this case because it's clipping through because you're transforming the static shapes. It's not clipping through because the particles are moving too fast. So clamping the speed won't really do much in this case. But if it is clipping through because of a speed issue on the particle side, then this can help clamping the speed. And acceleration is clamped by default. This is approximately terminal velocity in Earth's terminal velocity. Okay. So any questions regarding that, Somil?
No, that makes sense. I just had one more thing. So I think this is also one more question I'd put in as well. So right now the boxes are moving, but I've chosen them as a static shape. So would it be better if I had chosen it as a dynamic component?
So in the case of Flex, we only support static shapes. So switching it to dynamic won't actually do anything in this case. Yeah.
Okay.
Yeah, I think that was your next question, right?
Yeah, that was the next one. Yeah.
Yeah. So in this case, unfortunately, yeah, this is what you have to do here. You have to use a static shape and move it. There's no real way around it right now. Okay. So your next question, what does the diffuse particles parameter in the Flex solver do?
Yeah.
Diffuse particles, yeah.
Yeah.
So the diffuse particles are actually a secondary particle system that doesn't that happens as a result of these particles here and the movement and velocity of them. So just by just enabling it, you won't actually see anything in any of the actor components because it exists independent from any of them. It's more of a simulation particle, and so they're sort of these secondary passive particles that add additional detail, like splash or wave would, or foam or something, right? So that being said, if we allocate, so basically when you have diffuse particles, you allocate a certain number of particles and the simulation will automatically spawn and kill these particles. And they're spawned based on the diffuse threshold, and admittedly this is a bit vague, but it's essentially spawned based on how fast the particles are moving here. And this is an equation between divergence and kinetic energy, so essentially how fast the particles are moving. And this is the effect of gravity on the diffuse particles, the counter force, so how fast they'll be slowed down, and this diffuse ballistic. So the way the velocity of the diffuse particles is defined is by its neighboring particles. So if you have a diffuse particle and it has 10 particles, regular particles from actor 1, say, as its neighbor, then its velocity will be determined by its neighboring particles, and so it'll sort of flow through the liquid, so to speak, or at least that's, yeah. And so what diffuse ballistic is if it has less than 16 neighboring particles, the particle will be considered ballistic, and what that means is that it's just a regular particle flying through space affected by gravity. So its velocity is not affected by its neighboring particles. So what you'll see is essentially just a particle flying away. Okay, so how do you use particles? So similar to the way you'd use the flex top, and you would let's call this diffuse, and you would grab the diffuse position here, and this will give us a warning that we don't have any, so we have to restart the simulation here. And so the simulation will just create diffuse particles as needed based on the simulation properties. And so you can see here, it's actually using all of them that we've allocated. You can allocate more, and it will use as many as it needs. Now we can decrease the lifetime of this here by a lot, and you'll see now that it's going through them much faster. So this is in seconds here. So if we had, so this is approximately 1/10 of a second that the diffuse particles last for. And similarly, from getting diffuse position, you can also get the diffuse velocity here. So you won't be able to see it too well right now, I imagine, but what we can do here is maybe copy this, and let's bring this down here. Bring this down here, and we color, and just use this one instead. And let's see here. That definitely. Oh wait, that's the velocity. Sorry. There we go. Okay, so you're not gonna be able to see them very well. You can see it's a little bit more. It's a little bit more muddled, right? So if we turn off the render flag here, so it looks like there. We turn them on, and so it's hard to see it right now just because of the output there. It's a bit muddled. Does that make sense?
Yeah, that makes sense. I mean, I can see it a little bit as well because it creates a bit more depth to the fluid as well. Like it looks more like water, basically. Like you see the little splashes. Like I can tell that there's a little bit of a difference. I actually didn't realize that the flex top could pull. Like I didn't realize that diffuse particles was a different set of like instances that I needed to do. So that's really good to know.
Yeah, yeah. And you can instance it here in the same way that you're doing with this. You could even color them in a specific way. I mean, right now it's just white, right? We could do this, do the diffuse velocity, maybe just so that they're more apparent. And turn on the render flag. So that makes them very apparent.
Yeah.
And you can see the ballistic particles here. So if we move all of this down, oh, it's still hard to see just because of how much is going on there. Yeah.
Okay.
So. All right. So that makes sense then.
Yeah. Yeah, that makes sense.
They exist independent from any other particles in there, and they're spawned, but they are directly related in that they're spawned from the velocities of these other particles, and their velocities are directly calculated from their neighboring particles. Okay. So the next question you had is a bit of a in-depth one. So what sort of rendering techniques or post-processing can we use to make the simulation look more like a fluid rather than a bunch of particles? So I don't know if I have a altogether satisfying answer. I don't really have a good answer for this right now. It's sort of a missing piece in Flex at the moment. Fluids in Flex is being able to render it as actual water. But maybe I can go through some post-processing techniques with you. You mentioned that you tried using bloom and blur to get them
Yeah, I got a nice little jelly-looking substance though.
Yeah. Yeah. So out of curiosity, what did you use to do that? Just like the blur top or something?
Yeah, so I firstly I did a render pass just to get the particles in, and then on that I used blur and bloom, basically.
Okay. Okay. Did you try using um, did you try using edge top or something maybe to get some because like the problem I would think with blur is that you end up with something that's kind of not very clear anymore, right?
Yeah, well, I mean, what I would do is using a composite, I would limit how much the blur is like visible. Like, so mostly you'd have the particles, but what you would get is like a little bit of the edges are kind of softened out, basically, and
Right.
the lighting on on the particle itself.
Did you use a material with that or?
Well, I mean, I just used, I think I have a couple of other ones that I used on my Instagram. Let me just open up the file and I'll make sure because I don't recall completely.
So one thing you could try here is to use just a constant material. It's gonna flatten them out a bit here, which let's stop rendering the diffuse actually. Which will make it easier for blending them together than if they're because by default it just uses the Phong. So yeah, we can try something here. So we can go through use render pass here. Geometry, Geo1. So now we have just the liquid here, and maybe we could try. I don't know. We could try Luma Blur or something.
So I just opened up the other patch that I had. So what I had done is on the render pass, I put it through a feedback. And on the feedback, I done level, blur, comp, and basically leveled it out again and comped it to the main render. And then I attached a bloom, another level to do that, and then just comped it all together with the main render.
Okay. 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 And I guess so. Yeah. I mean, that's really what you're limited to, right? Is doing some post-processing techniques. At the moment. I mean, we do provide data here, like anisotropy and density. If you do want to, like this is the info here that you would need to actually render it as a fluid. We just don't provide any way built in right now to do that. And yeah, that is a missing piece of the puzzle right now. But one thing that you could do maybe, so we have this here, and so we can, let's just go here, we can blur it a bit, maybe add an edge. Oops. Maybe add an edge, just add some sharpness back. And one thing that you can do as well is you can change the size of the particles to make the simulation feel more dynamic. So if you instance the scale on the instance operator on this Geo1 here, if you instance the scale with the velocity, then the particles will be stretched along the movement vector, which can give it a bit more of a dynamic feel. I don't know if that's what you're looking for, but let's just try that here. So if we do, let's just take the root here, and this is just to I'm just taking the root here and maybe lower this number here, just so it's not such a stark scale. So then we can go here And that might be too much. And what you get is particles that are, the faster they're moving, the longer and larger they are. So you can end up with a bit more of a dynamic simulation there, instead of all the particles just being the same size.
Oh, okay, yeah, that looks a lot better. Yeah.
Yeah, and I've sort of softened this a bit, but you can make it quite a lot stronger here, or lower that even a bit more. Let's see, and yeah, so I don't know if that entirely answers your question, but
So just let me put you a little bit on the spot. Are you planning on adding fluids? Like, is that something we can look forward to?
like fluid rendering?
Yeah, fluid, because you mentioned that the components that you needed to render as a fluid were there. So are you planning on developing it further so that we can actually render it as a fluid?
There's no hard plan right now, but it is something that we would like to do. Yes, but no, I mean it's a good question, and a lot of people want to see it. I know, so. So I noticed here on your Flex Solver component, you set the subsets to 4 and the number of iterations to 6. Was there any reason for that, or were you just playing around? Just curious.
I was playing around, and that's what seemed to work for me, because I think if you have it too high, then they're too like densely packed together. And I can't exactly recall as well, but it was basically through experimentation I got to those two values, and I was like, this is where I thought it looked good, basically.
Okay. Fair enough. Yeah. Because my understanding of the way the number of iterations works, I mean, it's not entirely transparent. It's just that it runs the simulation step multiple times and sort of averages it out, because it's not entirely deterministic the way the particles interact. So you'll end up with something smoother the more iterations you have. It can affect performance though if you increase it a bit too much.
So that's what I noticed that, and that's why I had scaled it back basically. So that's what at least with the desktop that I work on, I only have an RTX 2060 on it. So if I went past too many iterations, because I already had, I think, about like 50,000 particles in there.
Yeah.
So like my machine was not happy basically after a while. I was seeing frame rate drop. So those were the numbers that I thought where it was like a balance between performance versus like visually it looked good.
Yeah, right. And so yeah, you did it to mostly like it was just the result of what looked good. And did you play around with the properties on this page at all as well, or
on
like
the solver?
Yeah, on the solver.
Yeah, I did. I went through quite a bit of things in the properties. I think but I didn't go into Xform or anything like that. So, but I did. I changed. I think the buoyancy is also kick reactive.
Yeah, it is. Yeah. So the buoyancy here is the effect of gravity on the fluid particles.
Yeah, and then
so
I mean, I played around with them all. I mean, I have, I sort of looked up some of the ones and what it meant as well. And I think I messed around with clamping speed and clamping acceleration too. But I found that like the default values kind of worked for me for that.
Right. Yeah.
So, and I did play a lot around with the particle radius just to get it like kind of look right.
Yeah, exactly. And you can do things with the particle radius, like having the particle radius a lot smaller than what you're rendering, or a lot bigger to do different things. Of course, if the particle radius is a lot bigger than what you're rendering, you'll have a lot of holes in it.
Yeah.
One thing I would say that one of the most important properties in the solver here is the cohesion, which basically just defines how the fluids interact, or the individual particles interact with each other. So the lower the number here, the more independent the particles are. So if we up this value, you'll see that the particles more move now is like sort of goopy down there, right?
Yeah.
And so that's just another thing that you can do. And dissipation, similarly as well, which will dissipate the velocity based on how many neighboring particles. So more dissipation means that the fluid will move a lot slower here, because if you have a lot of neighboring particles, then your velocity is going to be dampened quite a bit. In this case, it doesn't create quite as nice of an effect, though. You like a lot of nice, fast-moving, independent particles through here.
Yes, I think I actually had changed. I think the default value of the cohesion, what it was, I had changed it originally because I wanted it to be a little bit more splashy looking, basically.
Yeah.
Because I figured that's how basically cohesion and viscosity was basically, I figured out the balance between those two is how you get like, you can change it from like a viscous, like sort of goopy kind of thing, and then to change it to more sort of like a less dense fluid, basically, I think.
Yeah, yeah. All right. Yeah, and I think now maybe we can add these particles, the diffuse particles in here and see. Let's see here. So we got these. These have the same material here. Yeah, they're quite large though. We can try doing the same thing with the velocity here as well to scale it. Grab the diffuse velocity, and let's just scale this as well, like that. Let's see what that. Yeah, it's a bit too strong at the moment. So if we add math.
Greg was suggesting also to use the normalized split view on the mass top maybe right now, then people can see how that can be helpful when analyzing those values.
Right, yeah, yeah. Yeah, so in this case it's the X, Y, Z here, and which is what is used for, so the X is in the R, or the X is in the R channel, Y is in the green channel, and Z is in the blue channel. This is how these are formatted here. So, and that's the case with the position as well. Let's see. So, okay, so if we lower this, and yeah, so you can see the diffuse particles there a bit better now. They're not quite so strong. So that's without, that's with, without, with. And going back here, if we lower the diffuse ballistic, with diffuse ballistic set to 0, because when what this parameter means is if you have fewer than this number of neighboring particles, you will be ballistic. So if it's set to 0, there won't be any ballistic diffuse particles created. So all of the diffuse particles will flow through the fluid. And you can kind of see them through here at the top. Here, they're the white particles there. It's harder to see them up here because of the fact that this is white as well. Maybe we can lower this a bit, darken it all up. Yeah, there, so that lets you see the diffuse particles a lot better now. I mean, part of that is the edge here too, because this is there. So now yeah. So anything white here is a diffuse particle that's being created by the simulation.
That's pretty cool. It looks I like how it kind of like simulates the kind of foam you'd get like if you have a wave crashing or something.
Yeah, exactly. Yeah, that's that's the main addition, I would say. Yeah, it basically adds some extra flavor to the fluid instead of just having a static number of particles there. Particles can be created and fly away as the fluid hits a wall or something like that. Okay. So you had a question about frame rate lag when you had more than 16,000 particles, right?
Yeah, so I actually realized that was because I was rendering my spheres as a mesh. I mean, I think that was like a newbie mistake, I guess. So I got better results with when I turned it into a polygon and messed around with the frequency a bit.
Yeah, for sure. Because I mean, the default sphere when you put down the sphere soft is a mesh, right? And it's relatively detailed, and so you can easily run into problems if you have 16,000 of those in your actor component. So yeah, I would, especially if you're rendering it just with a constant material like we are here, just a flat white, and then you have the color operator just from the texture. Yeah, you don't really need too much detail on the sphere. So yeah, that's a huge performance factor there. Yeah. Okay. So some other questions you had were you had difficulty trying to use complex geometry as a collider object for the fluid sim. Do you want to talk a bit about that?
So, I mean, I tried using a couple of FBXs I downloaded off the internet, but they were pretty complex. Like, you're looking at least about like 50,000 vertices, basically.
Right.
So it's pretty complex geometry. So I was already skeptical if I was going to be able to handle it, because I even tried using just a plane that was where I used chop2 and used noise to displace the vertices. Even with that, it was struggling quite a bit when it was already maybe around like maybe just 200 vertices. So I'd like it'd be nice to see like if there's a way to use more complex geometry, if there's like a way you can maybe like store the values if it's not moving.
So is this geometry that is like a static shape, like you have here, like the same thing you have here with these, like with the box, I guess?
Yeah, so it was a static shape. Yeah,
Okay.
But it's just I'd see like really a lot of like frame rate drop. Like might be just that my machine's not as powerful as some others, but basically it was a pretty complex. It was pretty complex geometry. Like I knew it was going to be a bit of a challenge. So, but I just wanted to push it and see what could be done. But I never really figured it out. So I kind of like abandoned that because I was seeing it was basically I wasn't able to use it. So I kind of abandoned that thought and moved on from that and haven't looked back at it since.
Yeah, you could definitely run into problems if you have a really highly detailed mesh, because it does collision based on each polygon, so it constructs a triangle mesh. And so if you have a lot of polygons, then and you have your fluid basically lying entirely on top of it, then that's a lot of collision calculations that the simulation has to do. So one solution to that, if you do have a really highly detailed mesh as well, try and simplify it down. What the collision is and what is being rendered, or what the collision object is and what is being rendered, don't have to be the same. So on the actor component here, this one here that you're using for these blocks here, you can specify So currently, for its collision object, or for the collision object, it automatically uses any SOP that's inside of it that has a display and render flag on. So that's what it does implicitly. But if you want to be explicit and set a specific collision object, you can specify that here with the collision SOPs parameter. And so what you can do if you have a really highly detailed mesh is simplify the mesh down to something that has fewer polygons, set it as your collision SOP rather, and render something else. So you render the more detailed mesh, but what's actually colliding with is the simplified mesh. So that'll improve your frame rate, certainly, because there's a lot less triangles that it has to calculate for colliding with, especially if you have the fluid completely on top of the whatever mesh it is. But that being said, let's try something with FBX here. So just say, first of all, I've done FBX. Let's just grab the humanoid FBX here, import it here. So you can see it flying by there, but we're not actually using it as an actor right now. So first things first, I guess. You can grab the assets from a FBX component using the import select operators, and in this case, we want the SOP. We'll just grab the T-pose of this humanoid here, not deformed, just the T-pose for now. Okay, so we have this mesh now. It's probably pretty large, yeah. Okay, so if we transform that down, maybe scale that. Oops. Transform that down, something more. Stop rendering this. Okay. So we create an actor component now and set it to static. This doesn't have quite as many points as the one you were talking about, only 1,600 points, but hopefully this can still showcase using an FBX. So let's just put in SOP here. We'll do it implicitly here. Let's see, collision shape out of date. Yeah, so let's scale this down a lot more. A lot more. And let's move it down a bit. Sure, we'll just leave it there. So let's see here. So now we have this static shape inside our simulation, and let's restart it. So if we look here, now let's turn this back on, spinning back on here. So if we look here, it's kind of going around it, right? It's kind of going around it. Like we can try spinning this to see if we can get some. Oh, good thing I saved. Let's see. Advertising break, yeah. All right. So.
Well, I mean, it's a little bit nice to see that, like, even as a dev, you probably have a really good, like, powerful computer, and you still experience, like,
yeah,
a bit much for it as well. So it gives me a little bit of hope.
Okay, so looks like there's some problem with that. Let's go back and use a different version there. Okay. So I'm not sure what the issue is there, obviously with the static shape in some way, but we got some advertising here, TouchDesigner in the background. All right, there we go. So, I mean, hopefully that gives you some idea. I mean, I can try and run into some issues there, obviously. What I can, so you had another question though about, it'd be interesting to see a workflow for how we could use a point cloud as the initial positions of the particle in Flex Solver. And we see geometry that dematerializes into fluid when we start the sim, right? So we do have that in the operator snippets here. We do have, in some way, that. So we have this teapot here. It's not the most detailed shape, obviously. I've just taken a file in from the. This is just something we package with TouchDesigner here. Subdivide it to get a bit more points out of it, and then use it as the instance operator here. And so it's sort of, in this case, it doesn't really work that well because I think the initial position of the actor component is outside the bounds of the outside the boundaries here defined, the plane boundaries of the simulation. So it automatically disintegrates here. Maybe there's a better example here. This one here. So you'll notice it does, the moment you hit start, initially it looks like a teapot, and then you hit start, and it automatically just like forms together. I think that's probably because of the cohesion here. So maybe if we make it completely independent and we hit start, it does hold together a bit. The main problem here is that we have particles overlapping significantly on this teapot when we're initialized, and then when we start, the simulation automatically displaces them appropriately so that you don't have multiple particles overlapping. So when they're completely independent, and i.e. cohesion is 0, the particles overlap very little, and their velocity is very independent. But as you up the cohesion, you'll see the volume of the fluid there becomes less because the particles that we do have are overlapping significantly, and you can see that here. So that being said,
so just one more question on that. So the teapot that you had, are the particles just rendered on the surface of the shape, or is it like packed throughout, basically?
So in the case of the teapot here, in this bowl, we have the actor here, and we have the instance page, and it's just instanced using P0, P1, P2. So in this case, it's the points. So along the outer surface, yeah.
Yeah, so I was more wondering because I think you'd get a little bit more density in the fluid as well if you could pack a bunch of like volume on the inside of the shape as well.
Right.
That's the main reason why I reference point clouds too, because that's usually how the data is for point clouds.
Yeah, you'd almost want to like if you had like a boundary, you could create like a voxel of the shape so that it's completely saturated with particles inside, right?
Yeah.
Yeah. I don't know off the top of my head. I don't know an easy way to do that right now. Though certainly.
Could you use as an instancing source something from the palette, like in the point cloud page it actually creates, or the point cloud section, there is a point generator.
Oh yeah, I've seen this one.
Which
Yeah.
does a volume, just to test if that would work.
Yeah, this should work. Let's see. So, and then we need to change. Let's see. So it doesn't create too many points, just 1,000. But yeah, you could do, if you could find a point cloud file that, I think there might actually be one here, point cloud render.
You can also.
Yeah, we could do. I wonder if how many points is that though? 49,000. Okay. All right. Let's see how this works. Okay. Looks banana-like somewhat. So then if we start, okay, so what's happening there is we need to scale this up almost because the banana is just too small so we have so many overlapping points that immediately expands to ridiculous size. Could try uniformly scaling this maybe. I don't know how well this will work, to be honest. Yeah, it's still very, very densely packed. You can see the moment I hit start, it's going to expand. Oh, actually, not as bad as I thought. There we go.
Oh, nice.
Severed banana.
That's really cool.
There you go, severed banana. Yeah, so it seems like for this, a point file might be the way to go then.
Yeah.
Might be the least amount of headache. I'm not sure. Oh yeah, this one here we package with TouchDesigner. We have just a couple of them, it seems. Just sphere and banana. Yeah. Okay. So let me see here. Did you have any other questions? I think that might be.
I think
that might be the full list.
That's about it. Other thing I just had, just going back a little bit, what exactly is the function of instancing in Flex Solver? But I think you answered that while we were doing that. So.
Yeah. So it seems like currently the instancing in Flex Solver emitters. So the instancing is done automatically, but we do leave some of the instancing parameters still exposed, so that for like color, for instance.
Yeah.
But at the moment, it doesn't work. So you'd have to use the workaround you use is the workaround you'd want to use right now, where you have a separate geometry component. And
okay, so it's because I was confused because I thought it was actually like maybe you could instance like multiple fluid emitters, like you know how you had the first example, I think in the ops snippets where you have 4 emitters. So that was something I was confused about. So.
No, it's just a bug, I think, where you can't use any of the instance parameters right now. They don't work. So, but yeah, you'd want to use cloning like we have set up here. So we have 4 emitters cloned, and then the transforms just rotated here. So that would be the way to instance emitters, so to speak.
So when you have them cloned, do they interact with each other, like the particles from one to the other?
Yeah. So all. So this is not related to cloning at all, but any actor component inside the simulation will interact with each other. So if you have multiple fluid actors, say you have these 4 emitters, and we put one just regular fluid, like say the banana we just created, and we put that in here. Then it would interact with all of these emitters as well. So yeah, any actor component in a single simulation will interact with each other. In fact, you can see here kind of the as they hit the ground, they sort of create this bubble, I guess, in the middle. So one thing I didn't mention is that you can use force fields in. Now you didn't have a specific question about this, but I left it out in the brief. Is that you can use force fields in your simulations here. So this is a snippet here which demonstrates a vortex. And so let's see here. So we start out with a box here, and how forces work in Bullet is there a force field with some radius, and the strength they have, if it's negative, it means that they bring the particles inside, they pull them inside, and if it's positive, then they push them outside outside of the radius here. So in this case here, let's just restart because they're too far away. So in this example here, it's just demonstrating how you would create a vortex. And that is done through the property page on the Flex Solver. And there's a parameter here called vorticity confinement, which basically, the lower it is, the less confined the vortex is when there's a force field. So if we up this a lot, say to 100, you'll see the vortex slow down, and it'll become more or less a sphere. There's still some spinning here. You could up it a bit more, but if you lower this down, they'll spin around the center, and this will slowly speed up now.
There was a question by Greg as well. He was wondering if you could show anything on Flex Solver feedback.
Flex Solver feedback, okay. Okay. Let's see here. Okay. Let's see. Let's just make these here. Just to remove the mouse interaction. Yeah, so Flex Solver feedback. So on the Flex page here, so if you've used Bullet at all, Bullet has the feedback chop, which you can use to feedback all sorts of data to the beginning, at the beginning of the frame, so that so if you want to update position or velocity, you can do that on a sample by sample basis, where each sample is a specific body. And in the Flex case, this is done using the Flex top instead of the Bullet Solver, which is the same as the Bullet Solver chop in Bullet. And so if we wanted to feedback here, we would grab something through the Flex top. Let's do velocity. It's a bit easier to do than position. So we have this here. We have some velocity, and if, let's say here, let's put this in null, and let's feedback. So you can either feedback, you can give it a position feedback top or a velocity feedback top. Obviously, if you put the texture in these are both top references. If you put the top here, it'll feedback the position at the beginning of the frame. If you put it here, it'll feedback the velocity. So we want the velocity here. And there's a cook loop with the, okay, that's a bug, I think, but that shouldn't be there. But at any rate, let's see here. So what can we do? Let's do something simple. Let's use this as the input to get it the same resolution. And let's see. We can do this. You probably want to switch this to be 32-bit float, not 8-bit fixed. Okay, so this will So what I'm trying to do here is apply one velocity, one in the x direction here. And how should we do that here? So if we just plug it in, oops, you can kind of see it here. These are just being pushed in the x direction. It'll probably start to glitch out after a while, just because it's being pushed into a boundary. Yeah. And the simulation is trying to intervene and rectify. You'll notice these don't match exactly, just because this is grabbing it at the end of the frame. So there's and this is setting it at the very beginning. So the simulation will rectify any sort of conflicts. So if I try to set the position and I try to set them all to 1, 0, 0, every single particle, the whole thing would just glitch out because the simulation can't handle every single point occupying the same space. Okay, so what can we do with this here? Right now it's just applying this. If we just plug this in here now, it'll now just let go. The velocity is, we're not applying this feedback velocity here. Plug that back in. And we can try, maybe try using a switch or something here. Switch. All right. And I don't know, put a button down. Make it a momentary. Export that here. So whenever we press it, it applies the velocity here. So we just press it a bunch.
Sorry, Greg was just mentioning again, it's really useful now is to look at the tops in a normalized split kind of way, just because you're doing math with tops and not necessarily looking at textures.
Yeah, so here you have the three velocity, the three directions of velocity split here, X, Y, Z, essentially, in RGB. If we up this to something like 10, it's a bit. Let's restart this. Oops. Maybe open that parameter window. And then we hit the button, which will add 2 velocity in the X direction here, or we can maybe the Y direction is a bit better. 5. So then we go. Every time I click it, it throws the particles all up there. And it's doing it uniformly, so of course this can become more nuanced here. This is just applying 5 velocity to all of them up every time I hit the button. Yeah. Hopefully that answers Greg's question.
Yeah, so I heard that I'm a little bit quiet. Sorry if not everybody can hear me. But,
And Somil, you're muted.
So that was really cool because I feel like that's another way you can add sort of forces that are more, especially if you're doing audio reactive stuff. It's a
exactly.
Cool, it's a cool new way, different way to do it where you don't have to do it within the properties.
Yeah, exactly. Yeah, and this is sort of how you could make linear forces in Flex, because at the moment there's only force fields available through the force component. So this way, this is essentially just a linear force that we're applying here that we've put together. Yeah, there's definitely a lot of things you could do with this.
Yeah, that's really cool to know. I learned something that's gonna probably help a lot. So I'm gonna continue experimenting with this a bit more. Something
Great,
new
it's
to try
great.
out.
Maybe just a quick look here at the at some questions from the forum. One question was, we have been using basically spheres, right? Not sure, I might have missed you answering this already, but what's the, like, you can use just anything as a source for particle, box,
Yeah,
humans.
you can use anything, though. That won't affect the actual how it collides. How it collides is a solver property. So here on the property page, we define each particle in our simulation to have 0.1 radius, and so the SOP we use for the particle is not used in any way to calculate its collision surface. It's only this particle radius here. And so, yeah, that being said, you can render however you like. You can, I mean, obviously spheres are the most accurate, but you can render it as box or yeah.
Okay, great, thanks.
Good stuff.
Well, maybe a, so we have bullet, we have flex. Can you put flex inside bullet?
Yeah, I mean, in theory, I suppose you could, because you can get the simulation data from both of them, position and velocity. So I think the easier of the two would be to somehow inject bullet position and velocity into flex. Perhaps you override a static shape's position inside flex, maybe. I don't know. I think if I recall correctly, there's a user post about this on the website. I'm not sure the link, but we already did experiment with that. Do you have any recollection of that, Marcus?
I actually don't know. I didn't see that. Yeah. Another question, David Brown is asking, is there a workaround for dynamic sizing that would affect the simulation dynamic per particle sizing? I wonder, is that the collision shape, can that be dynamically sized?
No, unfortunately, no. The dynamic sizing we were doing there was only on the render. It wasn't on the collision size. So as far as particles go, you can only have uniform radius particles across the entire simulation too, not even actor specific.
Somil, there was a question for you from Greg here, which was, what was your experience using Time Machine Top in the earlier project that we showed?
Oh,
Or
I had a
maybe
lot
didn't
of
show. Yeah.
I had a lot of fun working with it. Because what I really liked about it was, so I discovered the Time Machine Chop when I was looking through a tutorial for slit scanning. And then when I realized that you could use any black and white image to sort of go back and forth between previous frames and the current frame, that was really interesting to me, and especially how you can change the values. You can have different frames at grays, and then you can have, depending on so you can use noise as well. So I thought it was really cool how you could use different patterns to sort of distort video that way at different points in time as well. So I don't know if that's like a standard way that Time Machine is used, but that was the main way that I thought was really fun, because I used a lot of noise and pixelate, and then I used a lot of I think the one that would look kind of like slime and was yellow. I don't think you showed that one, but it is up on my Instagram. So that one was just noise with the exponent really high and blurring the edges. So, and I love the beveling it creates when you blur the edges. So I had a lot of fun with Time Machine. That was probably one of the ones that I had a lot of fun with.
Yeah, that was very unexpected. Super cool.
Yeah.
Well, More yellow, please.
I did switch to the next screen because everybody was talking, so maybe. Yeah, practicing most Android ways was the time machine top, which is true. Everybody has like has so much playfulness to it that everybody has their own solutions. Yeah. So, well, what do you guys think? Is it yet late for you, Somil? Is it late enough?
My normal schedule is like 3 to 4 a.m. So like I'm just like getting started.
Yeah,
Right.
I think that really is one of the qualities of TouchDesigner people. It's stay up late. You know. Do you are you on, say, the TouchDesigner help group and some of the other communities online, Somil?
Yeah, so yeah, I'm actually quite, I've been lurking a lot mostly. Just, seeing what problems people have. I have posted here and there when I've encountered issues. I think I recently posted one where I was seeing some like slight, it was basically I was seeing some frame rate drop. And I think Francois, if I remember
Oh,
his name
Francois
correctly.
Renaud.
Yeah, Francois. Yeah, sorry.
Yeah.
So he
Yeah.
helped me out a little bit. It turned out it was a VSync problem too. So, I don't know if that's like a normal situation with. I was getting frame rate drop because of VSync for some reason, so I turned that off.
Yeah, I don't know
But
if
yeah,
that's
it's been helpful basically having that sort of access to kind of people more experienced. And most of the times I found they're really helpful and they'll basically go out of their way to try and like
yeah.
help you.
Yeah, and someone is awake at any given time of day or
Yeah,
night,
that's
right?
because when I posted that, I think it was at least like 1 a.m. here.
Yeah.
So I wasn't expecting like that quick of a response back.
Yeah.
So that's always also very cool. That's also why I sort of shy away from the doc, because I feel like from the wiki that you have for Touch, because it can get a little bit technical and sometimes like there's been a couple of times where I couldn't understand exactly what I wanted to solve, but I go on help group and they explain it to me and it makes sense.
Right. Okay. We won't talk about that anymore.
That's good.
Well, I think that was a really good session.
Yeah.
Perhaps a nice connection.
The doc is just more technical, basically. So for someone who's new, it's a little bit, not coming from like a programming background. It's a bit of a leap, basically.
Yeah, you mentioned earlier that your next thing is learning Python.
Yeah, so that's definitely, I think, because I want to start working with a lot more like data and stuff. So I've already managed to figure out how to pull out data from an API. So I'm working on that. I want like the installation that I have in design, we're planning on using pollution data, basically, air pollution data generated off an API. So I've got the API component done, but I think like to use the data and just massage it and sort of, compile because you pull when you pull from an API, you just get like one piece of data. So I think with Python, you can start like compiling a lot of things as well. And I think I've seen a lot of really cool examples of how you can manipulate data kind of using Python. And I think one of David Brown's really cool was there was a face that was mapped with all the nodes. I think that was all like Python probably because you can control the position of the node. So that was really cool. So I feel like it's a good step to take towards sort of being able to do more.
I think if you look up David Braun in the TouchDesigner community, you will find that particular asset. I could be wrong, but you'll find something.
Okay. Yeah, then I love his work. It's a little bit of a leap for me to try. Like it's something I aspire to, basically.
It's lots of resources also. If you look at GitHub as well, then you'll find more on the programming or scripting side. So that's a good place then to go and check out TouchDesigner on GitHub.
Yeah, I downloaded all the ones that David Brown has. It's just there's so much out there that's kind of like when I went through his repository, I'm like, okay, where do I start? So there's no shortage of resources with the community, that's for sure. So that's always
Yeah.
really good.
For sure, and the community has been hyper productive during this pandemic. So
Yeah, I've been loving
really,
all the tutorials that have been coming
yeah,
out.
yeah.
It's been great.
A huge thank you to everybody who's
Yeah.
who's listening to this right now.
Well,
And David brought one quick thing here. David Braun actually says, transform XYZ chop is a new great way to transform 3D into 2D screen space. Okay, guys, what do you think? Again, please, we've put the link in the comments, but TouchDesigner InSession, and if you read it and scroll down, you will find a form for you for anybody who would like to register to have to be on InSession and work with our development team. So.
Yeah, and thank you so much, Somil, for submitting, and thank you so much, Eric, for explaining, giving a really nice overview over Flex for everybody, including everybody at the company. Great.
My pleasure. Thanks, Somil.
Yeah,
thank you very much.
Yeah, it was really helpful. I learned a lot in just that like 45 minutes or an hour we had. So that was super helpful.
Glad to hear it.
Well, definitely keep in touch and let us know how the expansion of the TouchDesigner India community goes.
Definitely. Will do.
Okay, and thanks to everybody who watched today, and questions in the chat and suggestions in the chat, always really good.
Also up to Q&A. Alpha Moonbase is asking for a Q&A session.
Okay, let's go.
Yeah, next time.
Oh, I mean, do you guys have questions? Alpha Moonbase, is there a question?
I think he means a general Q&A.
Oh,
Yeah,
okay. But yeah, I mean, yeah.
Yeah. Well, that's a good idea. We can open that up this way. Okay.
All right.
Well.
Happy Friday.
Happy Friday, yeah. Have a good weekend, everyone. And stay in touch. Thanks, everybody.
Thanks.
Okay.
Yeah, thank you guys. Super helpful.
Somil.
Bye.
Take care. Talk soon.
Yeah, will do.
Bye.
Bye-bye.